It's Mark Sargent, and you can thank Anthony Riley for sending me this video. He said, "Hey, you should really narrate this because there's only music." Yeah, this is really important. This is some footage that was shot about 2 years ago in Santa Barbara, California, off the beach. And let's just zoom right into it and take a quick look. So this is another version of the oil rig observation. So the camera is placed in the guard railing between cafe and restroom showers. And you're going to look here. When we look at the elevation, it is set at 8 feet. So Google Earth reads this as 8 feet off of the water, which is a little higher than the 1 foot camera stuff that we did earlier. And then we're going to draw a line to the first platform, which is called Platform C, which is directly out in front of it. And then another one a little bit off to the right, which is Platform Habitat. And when we pull back and look at the distances of these two, we will notice the curve calculator, just to pull that up real fast. And then remember, this was shot October 23rd, 2017, so over 2 years ago at sunrise. The first one is at a distance of 6.08 miles, Platform C. And then the second one, off the distance Platform Habitat, at 10.1 miles. Why are these two important? Well, because at 8-foot elevation, the globe Earth's horizon should be less than 3.5 miles, meaning the horizon should be in front of these things. 29 feet of habitat should be blocked by the curvature in front of these objects. And yet, all of the habitat is visible, even with some compression. And you'll notice, and we'll draw a line here in a second, that the horizon is clearly behind these objects. And what makes this footage and all footage like it so important is that these are static objects, meaning these are not boats. These are always in one place. They're not moving or floating anywhere. And we'll draw the green line on this, and you can see, again, it's not hard to see. Somewhere way off in the distance is the horizon, way further than 10.1 miles. And that should not be. There's no curvature. And that only happens on a flat world. You will not see this on a curved thing, because eventually these objects should be over the side of the hill. They should be behind the curve. And we just don't see that. These two oil platforms, again, one at 6 and one at 10, are right in front. So tell me optically how that happens. Tell me what atmospheric condition can put the horizon behind these objects. You want to say it's a mirage? Okay, well, then if you do that, you can never say that a boat is being chopped in half by the horizon. Because you say, well, no, that's real. A boat being chopped in half by the horizon line, with heavy compression and refraction. Oh, no, that's real. But this right here, sunrise, couldn't be clearer conditions. Not a cloud in the sky, shooting off at oil platforms at 6 miles and 10 miles, respectively. You can't tell me that this is a mirage. No way. And even if you do say it's a mirage, tell me how a mirage puts the horizon behind the objects. That's the big key here. Do this with any sort of piece of paper. Bend it in half. Put 2 dots on the other side. Tell me how the horizon is behind those dots. If it's a globe, it cannot be. So again, share this with your friends, show people, look, this is one of the globe killers, but it's going to take people a little while to understand it, which is what you're looking at here is objects that are in front of the horizon, which is clearly a long way behind it, but these objects can't be if it's a globe Earth. Cannot be. The horizon has to be in front of these objects. The curve calculator, which mainstream science declared, that's pretty straightforward. So tell me how that happens.
Of Earth from space?
Great question. Why don't you ask NASA?
Because if I go on vacation to Branson, Missouri, I'm going to take a picture.
Let me ask you a question, Dave.
How do we not have a photo of Earth? And then people say, I see them we had Earth Day and all this stuff. This is one thing I had looked into. They're all cartoons. They're
CGI.
computer, CGI, everything's CGI.
They're all cartoons. They're all cartoons. So these are 9 images from NASA. This is the one that was on everyone's iPhone, right? And it's called the Blue Marble. And Robert Simon, a NASA visual artist, in an interview said how he made it in Photoshop. He was given data and he created it, used Command Z a lot. And he just created it and out of Photoshop. But then you say, well, what about the International Space Station? You know, International Space Station will show you this. Oh, look at this. This is cool, right? Wait a minute. Here's another one from them. It's here. What size is the Earth? This is obviously artistry. This is obviously a fisheye lens flying from a balloon or whatever. And it's wrong, right? So what can we measure? Well, here's one. This is the 2012, I think, image. And on Earth here, we can drive across Mexico and Baja and conclude that this is actually 934 miles. We could actually measure this. Okay, great. NASA tells us the diameter, a straight line through the Earth, is 7,917 miles. Okay, so now we have our scale. This is 934. I should be able to fit 8.5 of these between these two lines. 8.5 doesn't even fit in this frame. Okay, so this is a painting. It doesn't make any sense. All right, but people want to believe that that's where they live, but they refuse to think critically about it. Here's another one from NASA. You got Africa. You got the whole area here. Well, this is the map of the world. And the rest of all of this land has to be on the other side of this ball. Okay? Well, I can't make sense of that. It doesn't make sense. Well, yeah, it doesn't make sense. Okay? It doesn't make sense whatsoever. Right? And people say, well, they didn't have CGI back then. Well, how do you know they didn't have Photoshop, 100 years before they told us about it? Dave, do you think what would be harder to paint? This or the globe?
That.
Right. Okay. So if we look at
for one thing, because those are all things I can verify: a wine glass and a bottle, and like I have the dimensions of those things.
You can see the reflection and everything, right? This is a painting admitted by Robert Simon. This is also a painting. This is a photorealistic painting.
Somebody painted that.
This is painted, yeah. Zoom in on it; it's amazing. I think if you Google photorealistic painting, wine glass, wine and cheese, it'll come right up. And then you can see. So again, they're lying about everything. Okay, right?
so why aren't there then? Okay,
why aren't there? Because
why is not one shot from the moon? Just take 5 seconds to turn around and be like, what? Boom, take a picture.
Dave, if you're on an airplane and you're flying into your hometown and you fly over your house and you can see your house, you're sitting next to a stranger. What do you say to the stranger?
Hey, I can see I live right there.
That's my house. That's my house.
That'd be amazing.
You're the first guys on the moon. You're up there. You got your golf clubs. You got your dune buggy, right? You're doing a bunch of stupid nonsense. Wouldn't every other word out of your mouth be, oh my God, look at the Earth. It's directly above us. It's gigantic. It's 6 times bigger than we see the full moon. Okay. You'd be like, oh my God, there's the Earth. Oh my God, there's Africa. Oh my God, there's the United States. Oh my God, oh my God, oh my God, oh my God. That's all you'd be saying.
Mm-hmm.
They never once mentioned the Earth while they were on the moon?
Not one.
Not once. Wow. Never said, look at the Earth. Never once. Never, ever, ever said, look at the Earth. Okay?
So what about the space shuttle trips? How high are they compared to earlier you showed me a shot from the Red Bull thing. How high did you say that was? Like 72 miles high. How high is that in relationship to the space shuttle? And has the space shuttle ever gotten to a place where you could take a picture of the whole Earth in one shot? Or is it just, the
International Space Station? Neil deGrasse Tyson is now saying that you can't even see the curvature from there, although they show us the curvature all the time. Space Station supposedly has a live feed. And so we watch like, okay, here comes the space station. We go to their live feed and it shows pure clouds, but we're in a blue sky. Okay. They'll never show you a live feed at nighttime because you could oh my God, they just went over the football stadium where the Jets are playing and the Kansas City Royals, whatever. And you would see it, right? Because it's bright, right? Because they could see all these lights supposedly. But wait a minute, they're not the stadiums. It wouldn't sync up. So they never show you live feed at night. And during the day, it doesn't sync up with the actual clouds. They claim it does, but when you go verify it, never does, ever. It's all nonsense. Okay. So the International Space Station is 250 miles up, they tell us. Okay. 250 miles up, right? This Red Bull only went up 72 miles, right? But it's in the vacuum of space. It doesn't make any sense, right? Dave, when I put air in this balloon, it stretches the balloon out. And if I took that balloon up on an airplane, it would get bigger because it's just a low pressure. And then if I brought it into space, it would explode.
Yeah, even if you buy a bag of Doritos, you live in Denver or something, you buy a bag of Doritos, they're like puffed out.
Yeah. And so why doesn't this guy explode? He's in zero pressure. He should blow up like the Stay Puft Marshmallow Man.
And maybe they just have technology in there that's adjusting the pressure with the tubes because he's plugged into the ship.
You're making up stories, Dave.
Yeah. Well, you asked me a question. I don't know.
Yeah.
But that's what your brain does. Like, well, I don't know. I don't know how my car works. It just, this guy kind of just, the flux capacitor is doing what it's supposed to do. You know, you just kind of like tune out.
So
And so you just give these guys a lot of credit because I don't even know where you'd buy a suit like that. They don't sell those at Costco. It's like, I don't know. You just kind of give them credit.
International Space Station is probably the greatest construction project of all time. And there's zero photos or videos of it being built. Zero. Right? There's just an animation. And they never assembled it on Earth. And the different countries made different modules for it. And when they got up, and then they had to create an adapter because China made a different door and we made a different door. So they had to make an adapter. Never tested any of it. They built it in space. Never filmed any of it. There's no film, no photos. Right? It would be the most #1 film thing ever. Now all of a sudden, China has a space station. They forgot to film it also, and theirs is so bad. But if you find them faking space once, that's enough. But let's look at a couple things. Here is an astronaut, and all of a sudden, what's that?
Getting a bad feed.
We have glitches. Yeah, bad feed. Well, the whole thing would disappear, not just his body. Okay, not just his body, right? and then other times we have the colors inverted. Like, what is going on here? Okay, why are colors inverting like that? Okay, the ball turns blue, or face turns blue. Right? This is because they're doing they're using green screens and all sorts of stuff. On the space station, they're playing soccer. Things could break. Watch his head. It goes out of the area and his head disappears. It's hard to see that one.
Can you do that again?
Here it is. Watch his head. His whole top of his head disappeared.
That's weird.
That's a weird one. But let's just go through a few more.
It's like earlier with your globe soccer ball. All of a sudden there's like chunks missing in it.
Yeah, absolutely. So they're showing they're on the space shuttle and they're approaching the International Space Station. This is supposed to be real. Did you see it? It was just inside. How is it doing that?
Whoa.
That's supposedly the space station, right? This is a little toy model. And anybody that defends that is literally just lying to themselves, okay? Here's another one. So she's adjusting this window. She's got a rod that goes through that goes to this hatch, right? Somehow the O-rings are holding the air pressure in the vacuum of space. Is she looking at the door or is she looking at a monitor? She's looking at a monitor, okay? And she's trying to mirror, but her twisting of that knob isn't even matching. And then also, she's a short hair one. They wouldn't let anyone have long hair on the space station, okay? But this is worse than that. Look at her hair. Look at her face. Let's zoom in. She's got heavy-duty, perfect makeup on.
That is a weird
How do you
face.
put makeup on in space? Right? They always talk about conserving washcloths and water. How do you have this much makeup on in space?
And she's supposed to be on the ISS.
Look at her hair. Dave, that's a good hair day, wouldn't you say? Okay? That's a really good hair day. But they don't have showers up there. She's working out 2 hours a day, sweating her ass. Whoops, excuse me. Sweating her rear behind off. You can cut that out if you want. And look at her hair. Look at her makeup. Okay?
That makeup.
Dave, on my channel, DITRH, look up I Have to Go to the Bathroom is the name of a video. It shows the ISS bathroom. That alone proves they're not in space. It is the dumbest thing ever. Okay?
And that's your YouTube channel that people can put that in?
Yeah, YouTube channel, DITRH, or Deep Inside the Rabbit Hole. The internet,
That's where we are.
The National Buoyancy Lab. You know about this?
I've seen clips of them training in the water.
And so they're training in the water, And we're looking at the monitors, and all of a sudden on the monitors, we see a green screen. Why do they have a green screen? What could they possibly be doing with a green screen? Why do they have it greened out like that? Right?
You know what it insinuates?
It's because they're faking space. They're faking it. Watch Level with Me. There's a whole scene on how they do that. Check this out. Live feed. This is during a live feed. So we got the Dragon capsule right here. And look at its orientation to the Earth. This is from a different feed. So it's parallel and now it's vertical. It's just switching cameras. Okay.
Well, can you pause there 1 second? Hey, can you go back to that, or is this in a loop? Can we look at that?
I can do it. This one right here?
No, the one just after that where it shows the state there. Okay. Let's talk about that a second. So am I looking at that from a camera on another piece of the space station?
Yes, you are.
Okay.
So, but look at this. This thing is vertical to the horizon. Where could you move that camera to make this edge look parallel with the horizon? There's no place. Above, below, sideways. There's no possible way to get this to look parallel. Okay. But when we just switch live feed camera, it shows it parallel.
Yep. But I'm just thinking of the curvature of the Earth there, because that's the same kind of a shot they'll give you from,
Yep.
a very low flying plane, and compared to this is supposed to be.
Yeah, well, the curvature always changes, right?
250 miles above the
250
ground.
miles,
And that's like the Red Bull dive shot.
And the Red Bull was only 20 miles up.
But it looks like. But I'm saying it looks like the same thing.
The Red Bull. I'll jump over to that in a second.
Remember the guy
Red Bull?
He jumped out the plane.
Yeah.
But it looks the Earth looks the same at 250 miles above the Earth as it does in that parachute jump with the Red Bull.
So this is the Red Bull jump. By the way, they had 2 test jumps before that. They used regular cameras and showed a flat horizon. Then they switched to GoPros, and that's what they showed. But look at this. We zoomed in on this land down here and these little rivers and land features. This is all New Mexico. All of this from here to here is all New Mexico. Did New Mexico cover a third of the Earth?
It must. It must be bigger than we think.
There you go. That's my Glover boy right there. Okay. All right. So here's Felix getting in at ground level. And so this line shows the ground level. And here he is at 127,000 feet. Same camera, hasn't moved. Somehow, when he went up 127,000 feet, the horizon did not drop. That doesn't make any sense. The higher you go, the farther you can see. The farther you can see, the lower the horizon would be. Okay.
Wow. I mean, that's something that has to be reconciled. There's no way that they can't.
And whenever you see a curve, clip the curve and tape it on a ball. Okay, tape it onto a globe. This is how big Arizona should be. Arizona, I mean New Mexico. Sorry, New Mexico. So again, and then Felix, goes out there and he's like, I saw the curvature of the Earth. Now, is Felix a paid shill, or did he actually see the curvature of the Earth? He was wearing a curved goggles, right?
Yeah.
And he was told to mention that he saw the curve of the Earth. So he awkwardly fitted into the conversation, but he might believe it because he expected to see it. He's in where he can't take off his headset, his mask. He's looking through a curve. But the thing is, he's going to see a curved Earth on the ground, right? This is how much the Earth should have dropped, according to Google Earth. Okay, but it didn't drop at all. It didn't drop at all from ground to full altitude.
But the shot that they're selling looks the same at
both
72 miles high as it does as 250 miles high as it does as 20 miles high.
Yeah,
like they're using the same kind of CGI generated footage for every scenario.
Right. It changes, when you look at rocket launches, the rocket launches are absolutely the worst. Where they'll show you where is it, rockets? They'll show you Where is my thing?
Like, I don't know about all of it, and I couldn't explain this to a 10-year-old for sure. But
Yeah.
you could convince me of a lot of things before you could convince me that we've been to the moon with the technology they show we did. That just, it doesn't ring true at all.
Right. I mean, the moon landing is incredible, right? From the moon, this is what the sky should look like, but we don't see a single star from the moon. Okay. Well, the aperture wasn't set for that. They'll make excuses up all day long. But here is check this out. This is now look, we got the sun is over here because that side of him lit. And so we're gonna pan to the right, pan to the right, pan to the right, pan, pan, pan. And now all of a sudden the sun is over.
Whoa.
It turned a little bit. Hold on, it gets worse. And then he's gonna go over and pan to the right, pan to the right, pan to the right, and the sun is on the other side now.
How did it move so fast?
It can't. It's because he's on a stage and there's a row of lights, and that's the light. They didn't realize what was going on there. But there's something worse about this. Ready? Check this out. Here he is. Now look at his visor. 1 light, 2 lights, 3, 4 lights. There's 4 lights in his visor. Ready? Zoom in a little bit. Here it comes. And watch. You can see the first 2 already. 1, 2. And then when he turns, you're going to see the other 2. There'll be 4 lights. 1, 2, 3, 4.
Now, could those be a reflection from the person filming?
No.
I'm just trying to think of something like what would they say? What would be the counter argument? Because I already told you how I feel about the moon thing. I think the whole moon thing was like Stanley Kubrick or whatever. I don't know. It's just like it's so bogus.
It's so stupid. I mean, you look at the lunar rover, right? Look at this. This is an umbrella, right? If you zoom in on this thing, there's duct tape. Look at this, beach chairs. Okay, right? This is ridiculous. There's duct tape on these fenders, right? And this thing was on the lander, right?
And Nixon's sitting in his office on a rotary phone talking to him. Perfect.
Right. But look at this. This is the heat shielding. Okay, you zoom in on this. It looks like it's got open gaps and everything. Right. So there's 2 guys in here, golf clubs and a car in this thing. Okay,
and that's a real shot. That's not a replica.
This is the shot from the moon.
That's a moon shot. Oh man!
Look down here. This is the rocket, a single rocket. So somehow it lands with a single rocket perfectly. And they were worried. The big talk was they didn't know how deep the powder on the moon was, and they were afraid that the rocket was going to blow a hole so deep that the whole thing could fall in and they could all die. That was like part of the drama. But then it landed, and no problem. But if you look underneath, there's no blast crater. There's no blast crater whatsoever. Right? It should have.
It didn't just land kaplunk. It was rockets.
It landed with rockets. But now watch this. Right? This is them leaving. The thruster is down here, right? Ready? And all of a sudden, it goes boom. Where's it? It left the rocket thruster. So what did it just explode? And it's sending that up, and then it's going to meet. It's gonna just perfectly meet with the orbiter, okay? And they're gonna match up, right? And then who panned up? Did they leave a guy on the moon?
Well, did they have like a GoPro kind of a setting where they could pinpoint it for it to automatically track it?
This was a film camera. You can make up excuses. That's I know that you're just kind of shooting around.
Yeah,
but
I'm just like, because that's amazing technology now. You know, I'll say everything in the world has gone like this. Our phones, our cars, everything.
Across this video by Scientific Lee, and he shows a small-scale dome of water from a magnetic field. The research in the cause of the ME has led me to investigating the firmament with me coming across some disturbing evidence. But first I'm going to show how it is possible for a dome to be made from water by scientifically. All we need to do is scale it.
Those are just 2 pieces of marble that I've put in there. Oh yes, I'm not. There's the magnet, so it's a good eighth of an inch below the waterline. So I'll let that go so I can see it. Just come looking for the line, where's the pull that off the line, and I'm going to pull the line. Just have a bit more light. Just don't know if I've got the right light in. Oh, well, that's lighting of some sort. Alright. Well, that's it now, let's point it later. Alright, so let's take some more water out because I know there's a lot in here. So that's another one of them. Let's feel where it is. Okay, still an eighth, so we'll pour another load out. Another one. About a millimetre. Alright, I'll leave that and see if a dome appears in the middle, because them rings on the outside are raised, so it's already bulging at the very far edges.
It looks like the longer you leave it, the more the dome grows. Did you know stars can now be created in a lab? It's called sonoluminescent star in a jar. Let's have a quick look at this being done.
It looked like a star in the heavens.
Seth Putterman called it the star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together and heat up so much that the bubble gives off an incredible burst of heat and light, several thousand times a second, giving the appearance of a star.
I want you to take another look at the bubble before it implodes. This next bit of footage is me taking a picture and changing the colours to see what else is there. Check out what I found. This next bit is footage of the 2015 total eclipse taken from plane.
15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Viel Spaß!
They look like bubbles to me. What do you think? I believe the firmament is voltage flowing through water, and I am going to show you supporting evidence for that. You just need to think about scaling things up to the size of the dome.
Now here's another example of walking on water. This is a lizard from the Central America, and because it walks on water, it's called the Jesus Christ lizard. And of course, you'll say, well, I know the answer to this. The surface tension is high on water, but the common idea of surface tension is that there's a single molecular layer of water at the top, and this single molecular layer is sufficient to create enough tension to hold whatever you put there. I think this is an example that doesn't fit that. And here's another example, 2 beakers of water. You put 2 electrodes in, and you put high voltage between them, and then what happens is a bridge forms, and this bridge is made of water, a bridge of water, and this bridge can be sustained as you move 1 beaker away from the other beaker as much as 4 centimeters, sustained essentially indefinitely. How come we don't understand this? So what I mean is that there are lots of things about water that we should understand, but we don't understand. And so we really don't know. No. Also, the phases of water. Now, we've all learned that there's a solid phase, a liquid phase, and a vapor phase. However, 100 years ago, there was some idea that there might be a 4th phase somewhere in between a solid and a liquid. Sir William Hardy, a famous physical chemist, 100 years ago exactly, professed that there was actually a 4th phase of water, and this water was kind of more ordered than other kinds of water, and in fact had a consistency. So the question arose to us, ago exactly, professed that there was actually a 4th phase of water, and this water was kind of more ordered than other kinds of water, and in fact had a gel-like consistency. So the question arose to us, you know, all of this was forgotten because people began, as methods improved, to begin to study molecules instead of ensembles of molecules, and people forgot about the collectivity of water molecules and began looking, the same as in biology, began looking at individual molecules and lost sight of the collection. So we thought, we're going to look at this because we had some idea that it's possible that this missing link, this fourth phase, might actually be the missing link so that we can understand the phenomena regarding water that we don't understand. So we started by looking somewhere between a solid and liquid. And the first experiments that we did that get us going is we took a gel, that's the solid, and we put it next to water. And we added some particles to the water because we had the sense that something, the particles would show us something. And sure enough, you can see that what happened is that the particles began moving away from the interface between the gel and the water, and they just kept moving and moving and moving, and they wound up stopping at a distance that's, well, roughly the size of one of your hairs. Now that may seem small, but by molecular dimensions, that's practically infinite. It's a huge dimension. So we began studying the properties of this zone, and we called it, for obvious reasons, the exclusion zone, because practically everything you put there would get excluded, would get expelled from the zone as it built up, or instead of exclusion zone, EZ for short. And so we found that the kinds of materials that would create or nucleate this kind of zone, not just gels, but we found that practically every water-loving or so-called hydrophilic surface could do exactly that, creating the EZ water. And as the EZ water builds, it would expel all the solutes or particles, whatever, into the bulk water.
The firmament. All particles move to the bulk of the water. Which would be the top of the firmament. So is this where all the mud comes from?
However, in the history books, our teachers have told us that rats carrying fleas from China aboard wooden ships brought the plague from China to Europe, and it's total bullshit. That's not the truth. I go by what the historians were saying that were alive at the time, and not what we're being told today. So organic materials being fallen from the sky is nothing new. Charles Fort documented many of them. But in 1902, which was the last year of the Phoenix, this is what happened all around the world. And in some incidents in Oceania, there were ship captains that had to call all hands on deck just to push with brooms and whatever tool they could find all the red mud off their ships before their ships capsized. And these are written in the captain's logs. That's how bad it was. And Australia was one of the hardest hit for this red dust phenomena in 1901 and 1902.
One of the strangest places on the ocean's floor was only just discovered in the 1990s. I might agree it's one of a handful of people to ever see it in person.
Without a doubt, one of the most amazing things that I had ever seen in the bottom of the ocean. It was while filming for Blue Planet. It was in the Gulf of Mexico. And I noticed there's something out in the distance. Couldn't tell exactly what, but it looked like a dark band. And as we approached it, the dark band became a donut. I saw this donut that was black in the center. What the heck is that? And so as we get closer and closer to it, I noticed that the black band had what appeared to be kind of steam over it. And then I looked, and there was water lapping against the shoreline. This band was a ring of mussels. And inside the ring of mussels was a lake. And it's like, wait a minute, I'm already underwater. We went out over the water in this lake and tried to descend in it and bounced off. It was so super saline and dense that the submarine couldn't go down in it. We literally bounced off. And as we bounced off, we sent ripples heading back to the shoreline. It was insane. I've never seen anything like it.
And we began learning about the properties, and we've spent now quite a few years looking at the properties. And so it looks something like this. You have a material next to water, and these sheets of EZ layers begin to build, and they build and build, and they just keep building up one by one. And so if you look at the structure of each one of these planes, you can see that it's a honeycomb, hexagonal kind of structure, a bit like ice, but not ice. And if you look at it carefully, you can see the molecular structure. So, of course, it consists of hydrogen and oxygen because it's built from water. But actually, they're not water molecules. If you start counting the number of hydrogens and the number of oxygens, it turns out that it's not H2O. It's actually H3O2. So it is possible that there's water that's not H2O, some phase of water. So we began looking, of course, more into these extremely interesting properties. And what we found is we stuck electrodes into the EZ water because we thought there might be some electrical potential. And it turned out that there's lots of negative charge in that zone. And we used some dyes to seek positive charge, and we found that in the bulk water zone, there was an equal amount of positivity. So what's going on, it looked like, is that next to these interfaces, the water molecule was somehow splitting up into a negative part and a positive part. And the negative part sat right next to the water-loving material, and the positive charges went out beyond that blot. It explains, for example, the cloud. And the cloud, it's the positive charge that draws these negatively charged EZ shells together to give you a condensed cloud that you see up in the sky. In terms of the water droplets, the reason that these are sustained on the surface for actually sometimes as long as tens of seconds, and you can see it. If you're in a boat and it's raining, you can sometimes see this on the surface of the lake. These droplets are sustained for some time. The reason they're sustained is that each droplet contains this shell, this EZ shell. And the shell has to be breached in order for the water to coalesce with the water beneath. Now, in terms of the Jesus Christ lizard, the reason the lizard could walk is not because of one single molecular layer, but there are many EZ layers lining the surface, and these are gel-like. They're stiffer than ordinary surfaces. So therefore, you can float a coin on the surface of the water.
A coin can be floated on this fourth phase of water. Again, scale that up to the dome, and I believe it will become the impenetrable dome. I'm now going to show a talk on chemtrails by a doctor in chemistry.
Yeah, a lot of this spraying started back after World War II, and the nominal thing is that it is a way of protecting the albedo of the Earth. That by spraying these geoengineered chemicals in the sky, somehow it's going to increase the reflectivity of the Earth, and so much heat won't come in and that. I don't know that I believe that explanation, but that's what they've been giving us. And it's a little strange. I tend to think that maybe what they're spraying is magnetic chaff, and that they want to change the vibrational frequencies that are out, because if it seems like this planet has a poisonous atmosphere, maybe the aliens won't attack us.
It's a little strange because he can't think of anything that spraying magnetic chaff to change the vibrational frequency is being sprayed for. But I bet it wouldn't be strange if he knew about the firmament being made from the fourth phase of water, and these chemtrails are to latch onto the oxygen atoms after being carried up there by the magnetic frequencies that CERN creates. They tried in the 50s and 60s to blow a hole through the firmament. Do you think they gave up? They waited till things was understood more.
Compound in the whole world, 99 out of every 100 molecules is this one. And water is the major thing on everything on this planet, and that should be the ultimate focus of place where we can clean up and make a significant impact. But now let's talk about those chemtrails which spray out and then diffuse out. And by the fact that I was in the movie What in the World Are They Spraying with Michael Murphy back about 6-7 years ago, I became noted as the resident expert. And the three things we're really worried about are barium, strontium, and aluminum. And actually, the form that they are in the sprays are as the oxides. So we have barium oxide, strontium oxide, aluminum oxide, but notice aluminum oxide is Al2O3, and that's because the aluminum with its 3+ charge has to be balanced to the oxygen with its -2 charge. And so to get these balanced, that's why we need 2 aluminums and 3 oxygens. And this is called alumina, and that's one of the major components of what they're spraying. So why are these 3 the big bad guys? The major component of a biological system is water, but copacetic. Now, magnesium is fairly small. Calcium is about the same size as potassium. Strontium is a little bigger than calcium, and barium is a little bigger than strontium. But you see, if we were to substitute a strontium in for this magnesium, and that's what I think we're doing with the chemtrails, so we put strontium in it. Now, this is a bigger atom than was in it with the atom that belonged. And so, because of that, that's going to push this out of whack. This is going to have to be back here, and it's going to start breaking bonds and causing chemistry because you're putting a big molecule in place of something that was smaller, and everything has to spread out to accommodate it. The barium is even bigger than the strontium, and so now you can see when you get a barium into the lattice, first, it displaces a whole lot of things in the lattice. Second, it hangs on better so that you can't get it out of the lattice once it's there. So as where normal chemistry might have calcium substituting in for another calcium, and that'll work for a little while, and then another calcium will come in. Once a strontium or a barium comes into a porphyrin ring, it gets stuck. Now, yes?
Why are those getting substituted? What is it that's allowing? I mean, we're surrounded with all kinds of metals and chemicals all the time. Why are those getting sucked into the ring? Why is
this is an example of how the specific mechanism of a ring was only chosen because it's convenient to talk about. We could easily substitute it onto this molecule down here, in which case we have a calcium which is a lot bigger than the sodium, but here at least it's on the end of the molecule and can get swept off. The real problem with it is that, as I said, these things form as oxides, and they're stable in their charged form as oxides, and so when they stick to an oxygen, they think they're in their normal inorganic place. They're not really ready to go leaving the site they're at, and that's what holds them in, is the fact that the bigger molecules have a more finite attraction for the site than the smaller molecules do, and so the smaller molecules can't knock a bigger one out. Eventually that does happen.
Is that gravity?
Not necessarily. I think it a lot has to do with the size of the fit and the cavity that it's in and how much distortion it caused in a molecule. Because if you twist a molecule and it really is out of shape, the forces to put it back into shape are going to kick that off. But if you just make a subtle change and you make everything loose, what happens is that the components that get loose don't function as reliably, and so your mechanism for doing something like breathing and intaking oxygen might slow down because you've got things cluttering some of your sites because they wouldn't let loose like the molecule was supposed to.
Now, I'm no expert in chemistry, but what I was picking up from that talk was changing a smaller atom for a bigger atom will distort the structure and make it weaker. Now, there has been many floods in the past. There's been the mud flood that has happened all over the world and not that long ago. So is there a plan to flood the earth to bring the population down from 7.5 billion to 500 million, just as it says on the Georgia Guidestones? I think this needs more investigation, but we need some doctor in chemistry to find out these answers. I really do believe this is how the floods are being done, which means it is not God who is doing this. You are probably asking yourselves, why would they be doing this? Because they would be doing it to themselves. The answer to that is, we are living in a matrix. The Mandela effect is a side effect to them doing this. When man's intelligence has grown, they need to send us back to the Stone Age. All because they do not want to share control of the matrix with us humans. We could turn the earth into paradise, which I am going to show you some more of my earlier videos to show how I can make that claim. First, my 2-minute video virtually proving that we live in a simulation. Take a look at this picture. If I was to ask a friend to walk from pole 1 to pole 2, from my viewpoint, I would see him walk past the sun. But from his viewpoint, the sun would stay at the same angle to him. As you can see, this will put the sun behind the clouds for him, putting him in the shade. But I'm still seeing the sun shining on him from my viewpoint. So I'm seeing my friend with the sun on him, while at the same time and place my friend is seeing himself in the shade. This is two different realities at the same time and place in the same reality. How is this possible? The answer: we all see the sun from our own viewpoint, which means we see the position of the sun different to each other. And that means we see different places lit up by the sun to each other. This is only possible if we live in a simulation. We are all in our own little matrix, which needs to be connected to the collective consciousness for us to be able to interact with each other. Hope this makes sense. I'll start with explaining how the Mandela effect is being done. The changes that are happening to our reality suggest we are in a matrix, which we are. Which means there's a hard drive to hold the information to our reality. Through an experiment showing water holds memory, I know where the hard drive is. In the experiment, a listening device was used to record the electromagnetic field coming from the water to later reconstruct the DNA that was once in the water from the recording. This told me magnetic fields hold memory, so could this magnetic field be the hard drive to our reality? I got my answer seeing what looked like magnetic frequencies being aimed at Earth's magnetic field. Let's take a quick look at this being done by SpaceX.
With its own mind, is just shooting through the sky. This is absolutely incredible. Again, you're watching the SpaceX Falcon 9 rocket launch from Vandenberg Air Force Base, this visible from Bakersfield.
Did you see the many little spirals of magnetic frequencies shooting off Falcon 9?
And it does something here in just a moment that is really weird. Almost looks like something you would see in a sci-fi movie. Check this out. It starts spinning and it leaves these systematic lines in the sky. Almost looks like a radio tower sending out signals, like right there. Look at that. How weird is that? And this video was taken on the fly. She did not have a tripod. She managed to keep the camera very still and had a absolutely spectacular view of this impressive rocket launch that again left a large cloud in the sky that looked like a nova, some sort of a supernova. But the rocket's continuing on here, going in more of a slanted vertical.
I believe powerful magnets going off in a combination of positive and negative states to represent the ones and zeros in computer code. They do say at the basis of our reality it is the same as computer code in ones and zeros.
Pictures that contain all the information of a set of equations that are related to string theory. And it's even more bizarre than that, because when you then try to understand these pictures, you find out that buried in them are computer codes just like the type that you find in a browser when you go surf the web.
You're saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computers.
That is correct. So,
wait, I have to just be silent for a minute here. So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
Into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
Strings of bits of ones and zeros. Let's have a look at how data is stored in a computer to see if we can learn anything.
Imagine an airplane flying 1 millimeter above the ground and circling the Earth once every 25 seconds while counting every blade of grass. Shrink all that down so that it fits in the palm of your hand, and you'd have something equivalent to a modern hard drive, an object that can likely hold more information than your local library. So how does it store so much information in such a small space? At the heart of every hard drive is a stack of high-speed spinning disks with a recording head flying over each surface. Each disk is coated with a film of microscopic, magnetized metal grains, and your data doesn't live there in a form you can recognize. Instead, it is recorded as a magnetic pattern formed by groups of those tiny grains. In each group, also known as a bit, all of the grains have their magnetizations aligned in one of two possible states, which correspond to zeros and ones. Data is written onto the disk by converting strings of bits into electrical current fed through an electromagnet. This magnet generates a field strong enough to change the direction of the metal grain's magnetization.
The magnet is strong enough to generate a field that flips the magnetic bits. A magnetic field, just like SpaceX and CERN have been doing. Now, magnetic fields can carry the information, but what is acting like the magnetic bits? Let's carry on watching how a computer hard drive works and see if we can find the answer.
To turn it back into a useful form, much like a phonograph needle translates a record's grooves into music. But how can you get so much information out of just zeros and ones? Well, by putting lots of them together. For example, a letter is represented in 1 byte, or 8 bits, and your average photo takes up several megabytes, each of which is 8 million bits. Because each bit must be written onto a physical area of the disk, we're always seeking to increase the disk's areal density, or how many bits can be squeezed into 1 square inch. The areal density of a modern hard drive is about 600 gigabits per square inch, 300 million times greater than that of IBM's first hard drive from 1957. This amazing advance in storage capacity wasn't just a matter of making everything smaller. but involved multiple innovations. A technique called the thin film lithography process allowed engineers to shrink the reader and writer. And despite its size, the reader became more sensitive by taking advantage of new discoveries in magnetic and quantum properties of matter.
Quantum properties of matter. So what is in matter that could act like the magnetic bits? In all matter, it's the number of protons to the number of electrons that determine whether it has a positive or negative charge. And I believe it is the positive and negative charge that is acting like the magnetic bits. So you see, we could actually create paradise on this earth, and the dimensional beings from other dimensions aren't going to let humans have control of the matrix, because if they do, we could also control their reality, and they're not going to let that happen unless we make it happen. All I did with this was slow it down, and if you watch this footage here, you'll see when the light is on him, you'll see Van Diesel. But when it's not, the image jumps back to an image that isn't Van Diesel. So, see how it jumps back to an image that's not him, and watch when the light comes on. See how it jumps forward and jumps back when the light's off. It's a cloaking device to hide these dimensional beings that are controlling the world. It's hard to believe, I know that, but it's what I'm seeing from the evidence. It's up to you if you believe it or not. All I can do is show it you.